So one of the issues with the GTM is exhaust cooling. There's a small engine compartment and just a little place for the exhaust to go out of the back. So I've got a little bit covered up here, but underneath here you can see there's the exhaust pipe, and I've got a little bit of a heat shield up underneath there. But anyway, it's not just that, it's just getting hot air out of here. So the other thing is, so I've got the exhaust wrapped on each side, and the headers are wrapped down inside there. There's a fiberglass wrap that's coated with a ceramic coating. It's not a ceramic coating like what's on the actual exhaust. It's a little different. It's more like a paint that goes on the exhaust. And then coming up on the catalytic converters, which is right here, there's actually this stuff, which is a real thick material that has a kind of a white thick blanket underneath it. And then this is regular heat shield fiberglass wrap. But as you can see, as this stuff bakes off, here's some stitching. But as this bakes off, it discolors a little bit and it looks ugly. So compared to the rest of the engine compartment, it's not really that pretty. And then right here is the actual exhaust. This is a Kooks exhaust system. It's custom made for the car. It runs about $4,500 just for these Y pipes and the headers that go up there. So anyway, I've got everything out. I took my intake out. You guys have probably seen pictures of that on the website. And what I'm doing right now is I'm trying to engineer a cooling system. And the idea is to get cooling air from up forward here and bring it back to the exhaust. And I'll show you in a minute there's a big shield that goes over here. It's this piece right here. This piece right here fits over the top of the exhaust, and there's actually cooling fans that are mounted here, and the cooling fans suck air in here, and there's heat shields over the fans to block the exhaust, which flows right through this portion of this thing. Basically, it comes the exhaust pipe comes up and then runs through here, and then it Y's back. You'll see how it goes together. If you take a look on the website, you can see the picture with this thing mounted. And there's the other fan there. So the issue is obviously that with fans in here, most fans would probably melt. But what ended up being the case was I've got the fans. The fans actually fit right in here, right between the exhaust. So there's one here and there's one over here. And they're shielded from the exhaust. So not only is the exhaust shielded, the fans shielded and protected on all sides by both heat shielding inside that thing. And I'll show you the shields in a minute. But also on the sides here, there's end canal that surrounds the whole fan on the side structure of this thing. So you can see here, it's all end canal, and then up underneath on the inside, there's some pieces, some shields. And then what actually screws to that are these shields. These are the shields that actually wrap around these little turbine fans here. You can see they're metal turbines. They're just like little jet engines. They're kind of cool. You can see down in there. But these things spin at 52,000 RPM. I'm going to show those to you in a minute. I've been laying out the whole system on how this thing's going to work. I'll get to that in a second. But the idea, once all this stuff is mounted, is that as the car's running, there's a thermostatic switch that turns the fans on at 160 degrees. They're capable of going up to about 210, but I've got the fans coming on at 160. That'll help not only keep the exhaust cool, it'll keep the exhaust fans cool as well. So we want to try and keep the fans cool, and then all that air is actually going to come flowing right across the mufflers and out the back of the car here, so it'll exhaust all that hot air, but it'll be mixing with the cool air from up above the engine. It's a little cooler than down by the exhaust, so I'm taking that, mixing it, and then shooting it out the back here. So anyway, a fan here, a fan there, and then that protects it from the all that hot air, keeps it kind of back here. It'll pull the cool air in from the top here, and then pull it out there. It'll also be pulling cooling air out there. Now, in addition to all that, just so you see it, up under the car here, there's actually a cooling fan there. This is thermostatically controlled as well, but this is more meant for the transaxle. there's a whole cooling system up inside here. The cooling system basically taps the oil out of the transaxle here, runs it up through a pre-filter, then it goes through a Oberg tattletale filter right here, and then it comes out of that filter and comes this way, and then it goes into the cooler, which is a Citrob cooler. It's from NASCAR. And then it goes through the cooler and gets pulled, and then up inside there's a Tilton pump, and then that pumps it back to the forward part of the transaxle. So it's pretty I don't know, there's a lot of pieces on this the system here for the transaxle, and then when you combine that with the rest of the stuff in the back here, it's pretty complex. It's not the normal situation. The whole idea is to get heat not only off the transaxle, but you know, out of the engine compartment. Forward of the engine, all the floor panels are vented as well, so it's pulling cooling air there. And then of course up in the hood scoop, which you can't really see there, I've got everything covered up to keep from scratching the car, but the hood scoop actually dumps air just forward of that engine, or just actually where the window ends right there. It drops down on top of the engine, so it's getting the cooling air from the top, pulling it in here, capture some of that cooling air, bring it down between the exhaust, and fire it out the back of the car. So that led me to a really crazy wiring project here. So what I'm trying to do is I've got a thermostat switch that provides a ground for this entire system when it is running off of the battery on the car. Okay, but the issue, is most people know, is when you shut down the car, your exhaust and the temperatures inside the back of the car there will heat up and heat soak, and that's when you get some of the highest temperatures in that engine compartment because there's no moving air. So the concern is when you shut down, everything basically just shuts off. So not only do I want it cooling the exhaust while I'm driving if it gets up to temperature, I also want to have it cool after I shut the ignition off and get out of the car. That was the tricky part, so I need to time that to keep from draining the battery. The other thing I've done is I'm actually using an auxiliary battery just for that purpose. So here's what's going on here. So I've got a series of relays. That's going to represent the backup battery for now, so I'll have a larger battery. I've got two fans. Okay, I've got one there, I've got one there. I've got a speed control. These are radio controlled helicopter, airplane speed controls. They're 40 amps each. Okay, so they're tied together and they're wired in with a servo cable from a RC airplane. I've got a Y to a servo tester, which is how I can actually adjust the speed of the fan from inside the car. Later on I'm going to run a cable. I've got extra cable in here. It's servo cable. I'm going to run this controller up under the dash where I can reach it. It's got a tone also for different settings that you need to listen to tell you that that motor is ready to go. They don't turn on instantaneously. There's a signal that comes forward and you actually have to do it manually, which is, you know, I'm just going to deal with that for now, just at this stage. The complex part was just getting on all the relays and everything on here and getting this thing operating so I can actually, now that I've gone through the experimentation of the wiring and everything, I can actually start doing a wiring diagram and then take this stuff apart and you know, neatly arrange it in a control box that I'm going to make and then have that off to the side in the engine compartment away from the heat. It'll actually I'll cut down these terminal blocks and you know, neaten up all this stuff, shorten the wires and so forth. So anyway, here's what's going on. So this little box is a tester. It's putting out about 16 volts. It's a 12 volt power supply. This is going to represent my ignition on. That's the signal coming out of here. Okay, now I've got that running to these alligator clips right here, and these alligator clips are directly controlling a normally closed relay. So when no power is applied to this relay, it remains on. And the reason I'm doing that is so that when the system shuts off, this relay will provide power to the through the backup battery. Now, when the ignition is on, what's actually happening is this relay doesn't do anything because or when the ignition is on, it actually opens this relay, preventing the backup battery from controlling the fans. So it opens that, it shuts this thing off. This is a timer for when the ignition is off. This is the timer that runs the fan for whatever time I want it to run with the car off. So this is currently powered up, but if you watch it, when I turn the ignition on the car on, it actually shuts that thing completely off. And then when I turn the ignition, or the ignition is on, when I turn the ignition off, it goes into a counting mode. And it counts down from whatever time I want it to count down. So it'll run for a couple of minutes or however long I want it to, and then it'll shut off. So that's the idea with this particular timer. That's the only reason I have that thing there. That timer controls this relay. You'll hear it click in a second. Get 6, 5, 4, 3, 2, 1. Click. Okay? So that timer just ran out. That relay turned off. Okay? Well, this relay runs power to this terminal block, which is the main lead that goes and powers the large relay here. Actually what it's doing is it's routing power here and then allowing the power to go directly to the motor, but I'll show you that in a little bit more detail in a second. So we've got a backup battery relay, and then we have the main ignition relay. So both of these will power the fans. It just depends on the ignition switch, whether it's on and off. If the ignition is on, it's going to use this one. If the ignition is off, it's going to use that one. What controls that is the voltage coming out of the ignition, which controls the switching in this relay between the yellow wire and the gray wire. So when that ignition goes on, I'm getting positive 12 volts here, and it's going to ground here, okay? That bridges these two wires together. It closes that contact and takes car battery voltage through this heavy duty cable, which is simulated by this battery over here. That represents the actual car battery. And it's running and taking that battery power. When the ignition is on, it's using the car battery and running through this relay. When I shut the ignition off, what happens is this relay closes and it powers basically this relay. This relay closes, and then it pulls battery power from that battery, and that battery basically feeds into the terminal block for the motors. So either way it'll get power. So anyway, here's how it works. I'm going to go ahead and show you. So right now I'm going ignition on, and this relay is going to click. So you hear the little thing. So what that is that speed control that just went on. So when I turn the ignition on, the speed controller actually goes on. It'll go either way. So regardless if I'm using that battery or the car battery, you're going to see that speed control on. So basically we got the ignition power on. So right now I'm getting power from this battery. This switch is on. I actually jumped it. I'm not going to heat it up, so I just put the ground directly to the switch there to get a ground to the battery. There you can see it's on the black wire there. So with that on, this relay is on, and then my adjuster, this is the fan control, and it turns both of these. You can see the Y here. So the Y is that little controller controls both this speed control and that speed control. And then you can hear the fans. These fans are insane. They're like little turbos. Okay, so let's say those fans are running, and then I click on my ignition, or I turn my car off. It shuts it down. Now it's going to switch over. Now it's going on this one. And then it's picking up, so it's on the timer. Now that's running on this battery. Now when I go and I turn the ignition back on, it actually switches. Now it's running on that battery. Now I'm going to ignition off. Now it just stopped. The only thing is, when I go ignition off, I have to actually reset this thing, but it's going to be in the car. So I can actually, you know, before I get out of the car, I can say, you know what, I'm going to turn the fans on just enough to cool. I'm not going to run them full speed. I'm going to run them cool for a little while, and then I can control how much battery drain is, either through the speed of the motor or through the timing of the relay. There, they just went off. It just reached the end of the cycle, and I can adjust though. There's actually these little buttons down here. There's these are programming buttons, and you use to set the time, and you can set up to 30 different things that this thing does. It's really crazy. I'm using it for like I don't know, maybe a 30th of what it can do, but it's pretty crazy. So anyway, now that I mean, it's a huge mess here, but I had to sit here for a little while and get all this stuff to time correctly and everything. Once it's all tucked away, you can see the heat shield. The motors will be, or all the controlling circuitry here will be pretty far away from these motors. But you know, it should work okay in terms of heat. You know, and these things are like a dime a dozen. You can pick up these motors for about $10, $15, something like that. And they're Hewlett-Packard server motors. And originally, I took all the plastic rings. All these rings were like little ducts. They were on the front of this and the back and stuff like that. And what I did is I actually took the motors apart and I replaced the plastic with aluminum because they just happened to bolt right on them. And this piece is actually a duplicate of this piece, but it's off of another motor. So I just, normally it just has this section here and there's plastic here and then plastic here. So I added that extension to help protect that motor that's in there. But anyway, so yeah, listen to these things. It's pretty crazy. There's a lot of air coming out of these things. All right. So these things will actually move across the table. So that's that's on the ignition. I'm going to backup now. Let's see if we got a little more juice in this battery. See it moving. That's pretty crazy. This guy's scooting over there. It's dragging that whole line of stuff with it. There, my timer went out. It told me I can't play around anymore. Anyway, I don't know. It's kind of crazy, but you know, fun to mess around with sometimes. Experiment around with electronics without frying too much stuff. I did burn up a speed controller, hooking it up backwards. By the way, those motors actually came out of there. That's a Hewlett-Packard server fan, cooling fan, torn apart. And basically these motors, they sit on here, and they're on this all one assembly inside this case, this big case here. These things just shove into the big Hewlett-Packard servers. There's one together with the you know, with all the plastic and everything on it. So you could buy spares. That way, if if you fry these things, if it gets hot, I'm not too worried about it. You know, and really, I don't even need the fans. Probably this will be fine by itself. You know, the way it sits in there and everything. I mean, most people don't even have cooling on the exhaust. So this is completely experimental. And if I burn all this stuff up,